Hey, welcome to the office. And yes, it's still a mess. So it's been about 2 weeks since my last devlog. I've been busy, just doing stuff, like this. Let's just, maybe show you. But I've completely started from scratch again. So, like, just kind of pointing it out here. So we got a nice little demo scene and a menu system with my own font. Face, we have got some options here. I can go full screen. These will all can do things. The controls don't work. The controls don't work. Most of these are just placeholdered in. So let's go into free play. That's what I'm saying. So I can show you these. So you can go into low res mode. Kind of cool. That one puts it at 320 by 180. It's supposed to simulate like a widescreen, but more like a PlayStation or DOS type error thing. And then we can do this. Kind of cool. We got like EGA, 3-bit, or we can do dithered, 6-bit. Yep, it's all in here. That's what dithered. We got 9-bit, supposed to be like a PlayStation error. 9-bit dithered, I think actually kind of looks like a PlayStation error. Oh, and then when you go underwater, oh yeah, I went all the way down. So, I'll go back in there. We'll take there. Yep, got the underwater texture type thing going on. All goes down. So, yep, currently working on the physics engine. As you can see, I'm having some issues with the hovercraft. I don't know what it's doing there. It's like deciding it's going to read the water levels and be all weird and retarded. And it's at a 90 degrees, so I'm thinking that it's an issue somewhere with something is incorrect, like it's a direction or something. Because it's totally just going straight up 90 degrees all the time. But hey, the duck, the duck is there. And the duck is actually a physics object. If I go back to the main menu and reload the scenario, you can see the duck settling. Because it's actually dropping in, so that works. Alright. So, and, come on, dude. Dude, you're drunk. Stop it. This Mickey Mouse looking thing. Oh, man. Where this is actually, I have a texture map. That's holding my font data. That's just a font I created. And this is based on a multi-mesh instance 2D, which has a script which lets you expose some variables, so you can set it up in the editor like that. And then on each process, it decides if it's dirty or if we're in the editor, just to keep refreshing. If we're dirty in the game, it will totally redo the multi-mesh instance. No, it's zapping all the characters. And then the multi-mesh instance itself has a shader material and all that's set to do is just basically you feed it in that a few bits of data for where to draw in the texture based on what character you are. So it just draws that one particular character, and it can only do one string of text. It's meant for UI stuff. It's not meant for much else. So, and that's a replacement for their like their label and things. Like I was just trying to figure out how to do a bitmap font with those, and I said, I could do this. This is something similar I did with actually XNA back in the day. So let's close that. I don't need to save. And the other thing I have going on is there's actually something of a level loading system. So I go down here, I have levels. And you can see there's only the one bathtub level to load right now, because there's certain requirements for it to load. And then I can flag it so there's zeros for the demo scene and 1 is for that. And then when we go into a level, then, right, so it loads my scene, which it runs this, when it goes load in, go game flags. There's that flags value. So this is where it says equals 1, and I just put a note. Now, remember to make the duck quack. This makes the water in this scene false, because for the demo, we want the water to be visible. But actually, when the game's running, the water in the level isn't visible. What you're seeing, if I hack around the GODOT editor, but this is one reason to not code this directly with OpenGL or something, for sure, because you're trying to figure out all these different things. So we'll turn off the player 1 camera, and what is actually going on is the player has this view that goes around, where, the resolution, it's like about 128 units by 256, and the resolution of this mesh is it's like 40,000 polygons, and it's LOD'd and stuff. So, but if I wanted to subdivide this, say 4 to a meter, in each direction or whatever, it gets into like 100,000 polygons pretty quickly. Just hundreds and hundreds. And here, let's start up. So I don't have the wave simulation re-implemented for this yet, but I do have, yellow will be like a damaging wave or something, and as you can see, it actually picks up that texture, and yeah, that's that height field. And the way that works, because I did say I wanted to do a little bit of a devlog on that in the last one. So we have P water here. Here's its base, and that's what that. And all the trick is you have your shader, and there's all sorts of settings to this, but the key thing here is this viewport. So when it's running in the game, I have some code that latches it to this guy. And if I disable this is actually the, whatever is on this texture in this viewport will show. So I can put whatever image here, just sake argument, let's just grab here, just a quick texture map maybe. Here's the other. Oh, there, let's just add that real quick. It can't be white. So red is positive height amplitude, and green is actually a negative wave. And you do that so that you can additive blend anything that goes there, just adds together. So when each spot either adds all the way up, and if it's green, it'll subtract it. It subtracts it in the shader, and then blue sets that power level thing. But the thing is that it's set to not be linear. So when we're using it as not linear, what we get is this ability to. This will specify how many units up off of the surface. And as an example here, let's modulate green, which may be hard to see. Let's see if I can get in that a little bit. So I need some big blocks. Big blocky data. Alright, where's my thing? See, it's actually, it's so heavy, it's negated. Now, see, it's cutting its swaths in. It's pretty big. Here we go. Let me re-enable the player camera. This probably look pretty cool. So you can see it's actually it's making these divots into the world. And everything is under construction, so to speak. So okay, we're going to use a viewport thing as a texture, and one thing I do as part of that is this here. I take the vertex you get in the vertex shader, and I transform it back out into world coordinates. And then I say, okay, am I inside the world based on those other things? Okay, if I'm inside the world, the UV check into the texture is actually based on where I'm at in the world. So the idea is that if I'm, if I'm at 0, 0 in the world, I'm in the middle of that view support. And if I'm x equals 2 and z equals 0, then I'm just a little bit to the left or right, depending on how you actually organize the viewport. You just have to make sure your systems line up right. And then you're reading the point from that point. To get the normal, you have to take the inverse of the matrix 3 by 3 of the world matrix. This is the rotation matrix of the world. And then you're going to convert. So this would be basically the pixel to your right, and then the pixel in front of you. But because it has, you have to rotate it from the vertex you're getting, because the water itself rotates. This goes back to where this since the P water here is rotating with the player, that'll be even better to rotate everything. So because it's rotating it, it's not just it's not in line with the scene. It's not in line with the world coordinates. So you're taking the inverse rotation because you're saying, okay, so the water itself is rotated. I want to undo that rotation, and find the point that's to the top, up, and find a point that's to the left. That way I can then find the points to make a cross. There's a little diagram in here. See, you have point A that's at the top, B to the left, C to the right, D down. You find those points, and then you can go back into the wavesim texture and you pull out those points. And then you find a normal. And then this, when you do these calculations, when you've got dx, dz, okay? You know when something works and you're like, wait, why does that work? Yeah, I don't, I'm looking at that weird now. Like, is that supposed to be that? Anyway, I'll have to double check it. But you take the top line. It's a standard terrain thing. It's just you're doing it with the rotation thing because the P water is rotated. Because then you want a normal that is rotated along the same way as the P water. Otherwise, as you drive around, your shaded the shading just rotates with the camera. It's weird. So you have to fix that. And that's how you do that. And then there's also another piece here. This is what processes going underwater, and it's just a little rectangle with with its own shader. And that's actually depth-based shader in here. It just projects out. It says how far is the thing away, and when is that part underwater, and if that part's underwater based on the the lookup on the table or whatever, then okay, then I want to draw certain stuff on it. Okay, so that's all that is. So it puts all the caustics on everything. The bottom of the tub, as you can see, also already has some caustics on it, and that's more when you're above the surface because it's transparent. So because I have the foaming shader on there on the personal water. So because I have the foaming shader on the water surface, and it's a little bit of it looks through the surface, so you can see that's why the tub already has some of the caustics built in on the sides. It's just for that. It helps. And I guess I'm gonna have to get back to work there on figuring out why my guys flopping left and right like that. It's pretty good. It's pretty cool. That's happening. That's a thing. Interesting journey with Godot and everything. And certainly, you know, I can't wait to get back to get the new version of the Wave simulation all engineered when that one, you know, with the further improvements to realism and things. This has been a conversion. Like, I keep having to convert to some. I'll write a quick script for a player model or movable or something in Godot script, and then the main program is in C#. Like, that's the main thing, and I keep having to kind of convert, like rewrite one of the Godot, the GD script into be a C#, so that it's easier to, instead of getting some error like, oh, it's trying to access an array element of the wrong type, or how do I cast this or whatever. If I convert the GD script itself to being C#, then I don't have to worry about trying to load in the different types of the different class names and types and everything into the C# environment. It just recognizes it. So, like today, I just converted movable basically to being a C# class. So I can just access it directly. That should cut down. That should help with performance between the objects, at least in the sense of I don't have to run like get and and node.call and things like that going between the objects. Certainly I'm probably missing something as far as performance-wise between the two. But I can see that a naive approach with C# where you're just writing parts of it in one, parts of it in the other, might start to involve a certain level of thunking between the two types. And at the very least, if you have to thunk it once, it's probably worth saving that result. Like like I have an array of movable objects. So if my movables I kept as GD script and I only had to thunk them once, then myself having to convert scripts that were working kind of okay in GD script, and when I have to convert them to C#, just to make it easier to avoid casts and stuff within the C# side in the main engine, which is going to basically be a rewrite or my own implementation of the physics engine. I'm not completely certain how I would best integrate this wave height field thing with the Godot physics engine, which I've played around with before a little bit. It's great. It's wonderful. I'm not knocking it at all. But because I'm lost on this and that, I want a lot more granular control. I'm basically just going to write my own in C# and see how that goes. And not saying that that's for everything. I'm certainly not knocking what's built in. I'm finding that in general, like the Godot project to be very, very useful, and definitely like stuff works great out of the box. And if it doesn't work well for you, it's easy enough to find some way to engineer around it, to work around it. The tools are fairly well opened, and you always have the source code to fall back on if you're like, well, wait, how did they implement this thing so I can interface with it? But otherwise, like I have to convert like I had the movable objects were originally GD script, and then today I just converted them. It was a very short script. It wasn't a big deal, but I converted it just straight up to C#, because now movable is just a C# class. It's not, oh, I got an object, a node, and it's casted in spatial, and then I got to figure out how do I cast it to movable? How do I cast an array of movable? If I get the children from a node, how do I? Whereas I could just have an object, like have a variable or whatever in the object, and then okay, so that's the thing that has children, and then I can just read its children because I can just call it directly, and it's movable. Ooh. I'm sure I'm missing something in between the C# and Godot, like the glue logic and the bindings, but having everything be in one way or the other, or at least caching the result between the two, should be better performance-wise. Like, you want to avoid that thunking, because that's it's kind of going to be a big deal, a big kill is going to be the difference when you're switching between the two script systems. Because otherwise GDScript, not the fastest thing in the world, runs fine. I ran into issues right away trying to build my quad tree in it, but then again, the quad tree is so many calculations, it's so CPU intensive, and then every time it's going to run the quad tree, it's going to pull mesh instance dot multi-mesh instance dot get instance set instance. It's all these function calls that in C# would just be like a pointer lookup, and that's just kind of where the benefits are between the two. And certainly, you leverage whatever's useful in either one. For the UI code, quick little button, I'm just going to throw some GDScript at it. Why should I complicate my life? Why should I worry too much about it? Expose the variables I need to expose, and then it's easy enough to kind of link it in, monitor it from the C# side, or have the script with. Not a huge problem, especially connecting the singles between the two. It's very well integrated. So my next plans for this project will be, the next thing is just getting that physics engine rewritten. Well, the wave simulation rewritten, and then make it so that objects can actually just fall in and splash. Like previously, it was being called whenever the hovercraft was in charge of everything in the tech demo, basically. So now I want it to be just I declare an object as a mover. It's a physical thing. All right. If it crashes into the water, I want to see a splash based on how big it is, how much it weighs, whatever the parameters are. If it goes underwater, I want it to bounce back up, have a certain amount of buoyancy and weight. If it's flying in the air, I want to have gravity affected. That's very simple stuff. That's the next thing. And then also having the objects, of course, collide and be able to sit on top of each other, things like that. And then get everything so that waves can bounce off of walls, which I had not implemented in the tech demo at all. They just wandered off into space. Endless void. Right off the wave texture, I didn't worry about them. But, they're out there somewhere, sucking up CPU cycles until I closed the program. Or they were recycled into things closer to the camera, because there's only so many wave particles in the system at any given time. I go into more into detail on how I did that, or how I'm working on that, once it's working better, and also trying to figure out exactly how to calculate like a shock wave or blast wave of a duck's quack. What is the impulse it would impart on the intersecting surface? How do you calculate the intersecting surface between the wave as it's coming at a given object? Say the hovercraft or the water or whatever. How do you calculate that? What's the impulse it's it's going to impact in that time slice? And apparently it's calculus 3, so it's pretty complicated there. I'm not sure if I have the right formulas. Googling for shock waves and stuff gets some interesting results. I'm probably on some list somewhere, but that's how it's going. Alright, well, until next time, take it easy. Trying this thing, editing the video, I didn't realize what my problem was. So, in this function here, I had this lovely line of code right here. This was the original line of code. Alright. So, when it goes to calculate the rotation, I was saying, okay, so the float ring, on my movable objects, I have this floaty object. So the floaty object currently it's going to contain a number of children. They're just positioned 3D. So this specifies the points to check on the water where it should. So if it was floating flat, these are the points that should be that. And so of course it doesn't help it float upright. So it's really simple to this. Alright. So that object gets sucked in, and then here's my function for checking, if I should be doing water movement, and it figures out if we're in the zone for the water. Okay, if so, if we're not, it applies a little bit of gravity. It just says you're out of everywhere. Just apply gravity. So obviously at some point that might be changed later. But then it goes into this, and so here we have that spatial floaties. We get our floaties on from the length, and then we make array of vector 3 float ring. And here is the difference in the problem. The first few iterations of this code were not based on the global transform of the floaties. It was doing slightly differently, but now this will account for if we're already previously rotated, then obviously I wanted to account for all that. And as it rotates, around the y-axis and things like that, I wanted this to be where that flotation thing is in the world. All right, so now this is transformed out of origin. This is the global transform of these objects. Okay, and we get through all that stuff, and we get to the part where it says check floats is filled in here, where at each of those XZ positions for the float ring, we find a C for the water. So we get a height C. Alright. Then we end up here. This is averaging the water height, and this is averaging the float height. Okay, so there's that. Alright. So the float checks at C. At C, haha, that's funny. Alright, so the number of float checks at C. So now in this, we're saying that this float C is check floats L, the height of the water, minus the y of the float ring, the height of the float ring. Okay. 0. If the water is higher at this point, well, then we want to rotate the other way. That's fairly simple. So we want to rotate in that vector, to align with that. I had this one line of code in here. This thing. Yeah. What's this? This is the origin. This is the global. This is a global value. This is going to be way out there somewhere. And then I'm going to normalize it. It's going to be all kinds of crap. Nope, that's not the line. What I want is we can basically forget about we can do a little bit of normalization. We're going to say, okay, so we're going to throw in that, take it out of global coordinates by taking out the translation of the object itself. So minus the x, minus the z. Now for the y, I'm just going to add in c. So we get this amount times c, that amount times c, and then c. Alright. So at least up gets a vote. Is kind of the idea. And then I'm going to normalize it to 90 degrees. So somewhere it's a 90-degree rotation. And then I'm going to negate the y rotation completely, because I want the y rotation to be controlled by the player of the object. That just controls which way it's facing in the world horizontally. So that's how it counts the player turning. I don't want to mess with that, so I change that. And then because they're two equal, like the y is always coming up straight, but then you'll tilt a little bit one way or the other based on that. So this calculation really is only going to affect the normalization part. Let's just take that out of it. That's fine. Let's leave that out for a second and just try it without it. But we're definitely closer, because now this is relative coordinates to this thing. So it points to plus, minus. They're always going to cancel out. My object is 0. My object is 0 in its ring. The idea. So because my object is going to be 0 in the ring, and then we're only counting in the points where that water is higher, so it doesn't just cancel out. So now when I drive around, you can see it's randomly reading little bits. It's like adds like a 100th or 1,000th of a unit whenever it reads the water. So it's reading perfect 0, but it's tilting me back and forth a little bit. And I'm vibrating. And that's what I should be doing, given that data. Okay, but I'm not flopping around depending on what quadrant I'm in or anything. And so, go figure it out as a fix.